Copy 724, right. Center maintain 2000.
Center maintain 2074.
Comment 504 to center maintain 3000.
3000, comment 504.
Today we're gonna be talking about the aircraft performance. The first thing we want to cover is what are the main elements of an aircraft performance. So the main elements for the performance related the main elements related to the air performance are basically the takeoff and the landing distance. Then we have the rate of climb. Then we've got the ceiling. Then we have payload. Then we have range. We have speed. We've got the fuel economy. Then we've got the maneuverability and stability. And stability. So basically what it means is, like, when we're talking about the performance, we need to be concerned about these things. So now we want to talk about the takeoff and landing, the factors which are going to affect these two things. So remember how the takeoff and the landing kind of very the similar factors are going to affect both of them. Actually, all of them are going to be, whichever affects the takeoff should be affecting the landing too. And these are the factors. One is the air density. Then we have the surface wind. Then we got the runway surface. You can just call it runway for now. Basically, runway surface. And then we have the angle of the runway. This was like the runway, just the surface of it. Now the like the upslope and the downslope of the runway. And we're not talking about the like the magnetic direction of the runway. We're just talking about if it is uphill or downhill. And the last thing is the weight of the airplane. That is definitely gonna affect it. Okay, so what effect does wind have on an aircraft performance? Again, basically we're going to be talking about two things, takeoff and landing, right? And also like during the flight too. So the wind, right? Let's just divide it into three things now. It's gonna be easy to talk about that way. So first let's cover the takeoff. You're taking off. So the headwind, the effect is that you're gonna be able to, like, you will be able to reach the liftoff speed at a lower ground speed. Basically, headwind during the takeoff is good, which will increase the airplane performance by shortening the takeoff distance. Now, again, what if if the wind is in the if it is a tailwind, then in order to you're gonna have the greater ground speed to get to the liftoff speed. So it is not good because you're going to end up having like a longer takeoff distance. Now talking about the landing, very similar thing. Actually, the effects are very similar because the effect of the wind on the landing distance is identical to that of to its effect to the takeoff distance. Because again, the headwind is gonna make your landing distance shorter, and performance is gonna be much better. Whereas the tailwind will increase the ground speed, and it's going to decrease the performance by decreasing the approach angle and also increasing the landing distance. And the third one is while you are in the cruise mode, we'll just call it cruise flight. So uh, so basically in this one, you want it to be in the direction of the wind in order to take the advantage of the wind, because they work in the opposite, like the wind direction and the airplane direction, they are uh, like basically have the opposite effect on the like the airplane performance. If you have a headwind, it's gonna decrease the performance. If you have a tailwind, it's gonna be good for the plane performance. Now we want to talk about the weight. Okay, so the weight effect on the basically we're gonna be covering the takeoff and the landing, right? So if you have the increased gross weight, it can definitely affect the takeoff performance. What's gonna happen again for the you're gonna have a higher lift-off speed. You're gonna have like you have like slow acceleration. You're gonna have basically the drag and the ground friction, they're gonna be more. You're gonna end up having a longer takeoff distance, whereas the gross effect of weight uh, sorry, the effect of the gross weight on the landing is that the airplane will require a greater speed to support the airplane at the landing angle of attack. So in the end, you're gonna end up having an increased landing distance. Now we want to talk about like what is density altitude, and then we will be talking about altitude. Then we'll be talking about how it. I'm sorry. How does it affect the performance? Okay, so basically this altitude is the pressure altitude correlated for non-standard temperature, and as we will be studying later on, that the standard temperature is 15 degrees C, where we have the uh, but basically this is the density altitude is the pressure altitude correlated for non-standard temperature. Under standard atmospheric condition, air air at which the level at each level in the atmosphere has a specific density. Okay, and under standard conditions, pressure altitude and density altitude identify the same level. So basically this density altitude is the vertical distance above sea level in the standard atmosphere at which a given density is found. Remember that this one is not equal to the true altitude. Density altitude changes based on the non-standard temperatures. Okay, what are the effects of this density altitude, right, on the takeoff and the landing? An increase in the density altitude results in increased takeoff distance and reduced rate of climb, and increase true airspeed on approach and landing, which is gonna again in the landing it's gonna be increased landing roll. So more like more like the increased density altitude is not a good thing. It's gonna reduce the performance of the airplane. Okay, now we want to just talk about kind of very similar thing, that this no, so we were talking about the density altitude, right? Now we want to talk about the air density, right? The air density effects, right? So basically it has a direct effect on the lift produced by the wings, okay, and the power output of the engine, right? It's also affects the propeller efficiency and the drag forces. And in another point we want to cover about, like, we just named the things which are gonna be affected, but what kind of effect does it this air density has? So the basically if I divide these factors I just said in three things: altitude, temperature, and humidity, right? Okay, so the air density is gonna it's inversely proportional to the altitude. So the higher the altitude, the less dense the air is gonna be. So the relationship is reverse. The next we wanted to cover is the temperature. The warmer the air, the less dense the air is gonna be, and the humid. So again, uh, it's directly inversely proportional. Again, more humidity, uh, and we're gonna have less air density. So air density is good. We need the air density for the better performance, but all these factors are gonna be inversely proportional to the uh, air density. Okay. Then we want to cover about the again we already did that, but let's just make another point on that. The temperature, humidity. So how they're gonna affect the density altitude. Okay, no. So we're gonna be covering the relationship between this one and the density altitude, not the air density. Okay. So remember that the density altitude will increase when one or more of the following occurs. Density altitude is gonna increase if we have high air temperature, if we have high altitude, if we have high humidity. And just by looking at it and understanding that these factors are going to increase the density altitude, that means density altitude is not good for the performance, just because the temperature, altitude, and humidity is not good. Again, they're gonna the density altitude is gonna will decrease when like if the temperature decreases or altitude decreases or humidity decreases. Okay, so we're gonna be defining these things now. What is vs0, vs1? Okay, uh, vy, vx, vle, vl0, sorry, vlo, vfe, and then we got va, and I'm gonna be covering all of them in a second. vno, vne, right? Okay, talking about the first one here, which is the VSO. So the VSO basically is the stall speed in landing configuration. This is the stall speed VS1 in a uh, in a specified configuration. Like it can be a clean configuration or a basically like it could be any specified configuration where like they can tell you that okay, the VS1 at this speed, uh, like at maybe the flaps are gonna be this is the position of the flaps, and then what's gonna be the stall speed. So any specified configuration, uh, this is again calibrated. The VSO is calibrated at the power off stalling speed. VS1 is again in a specified configuration. Vy is the best rate of climb speed. Vx is the best angle of climb speed. And again, this is the gonna be where the basically uh, airplane will be, if you are flying at that speed, that if the airplane will be able to obtain the highest altitude in a given horizontal distance that is optimized for that. VLE is the maximum landing gear extension speed. So again the landing gear is extended, right? Not retracted. If your plane is equipped with that, it is extended. And what is the maximum speed you can attain by keeping the landing gear extended? VLO is the maximum landing gear operating speed. So what it means is like the maximum calibrated airspeed at which the landing gear can be safely extended or retracted. So you definitely need to have that speed, right, in order for the landing gear to extend or even to retract, right? In both cases, when you wanted to bring them back, bring them inside, or uh, retract, or what's gonna be the speed, what's the maximum speed you need to have. So this is the flap extension. So maximum flap extension speed, this is calibrated airspeed permissible with the wing flaps in a specified extended position. Again, with the VFE, they will tell you what VFE they're talking about. Maybe this is 30% of flaps are open and stuff like that. VA is the maneuvering speed, very common one. Definitely should know that. Maneuvering speed. So yeah, NO is the normal operating speed. NE is the never exceed speed. You should always keep an eye on that one. Never exceed speed. Like at any circumstances, the airplane airspeed should never exceed that that speed limit. Okay, now we wanted to say that we're gonna be talking about the charts, right? So what are the famous charts? Uh, like again related to the performance, and like we're just gonna go through their definitions. I'm just gonna write them down first. One is like the takeoff chart. Then we have got the fuel time and distance to climb chart. Fuel time and distance to climb chart. Then we got the cruise and range performance chart. Then we've got crosswind and headwind component chart. Crosswind and headwind component chart. Landing chart. Okay, then we've got the stall speed. We did cover the landing chart. Then there is stall speed performance chart. These are the charts we wanted to cover. Basically, as the name suggests, the takeoff chart is gonna it's going to help you compute the takeoff distance depending on the different flaps and the specific flap configurations. Fuel time and distance to climb is going to be telling you the fuel amount used during the climb, the time it takes to accomplish the climb, and the ground distance that will be covered during the climb. Okay, then the cruise and the range performance charts, they are basically give you the true airspeed, fuel consumption, endurance in hours, and range in miles, right? Those ones. Then the crosswind and the headwind, this allows for configuring the headwind and the crosswind components. Landing chart provides you like the basically the landing distance, uh, right, and then the stall performance chart is gonna be like they are designed to give you an understanding of the speed at which the airplane will stall in any given configuration. The last thing I wanted to cover is like the term pressure altitude. We did talk about the density altitude, right? So the pressure altitude, it's basically the altitude indicated when the altimeter setting window is adjusted to 29.92, right? And what is that 29.92? That is the inches mercury. So this is the altitude above the standard datum plane. Again, it's a theoretical plane where the air pressure is actually corrected to 15 degrees C equals to 29.92 inches mercury. Okay, and pressure altitude is used to compute density altitude. Also, the density altitude, true altitude, true airspeed, and other performance data. And there are formulas for that, like how you would actually be calculating these things using the pressure altitude.